Right. So we can start from question number 2, question 2, or even question 3. So whatever. So are you clear about question number 2? Hello.
I got like the first, like the max, like 50N and 80R.
Yes. So the first thing is we can easily understand that the max of the total exposure index. So we have to find if the value of the index for local newspaper advertising is 50 and the value for radio advertising is 80, how should the restaurant allocate its advertising budget to maximize the value of total audience exposure? So it's a maximization problem. First thing we know, it's not a minimization, it's a maximization problem, and it mainly depends on these two variables, how much we can change these two things. So amount of advertisement in newspaper and amount in the radio advertisement. So if you put 50 and 80 here, these are probably some factors or exposure index. So these are constant, but these are changing. These two changing and changing the overall maximum exposure of audience. But where there are different constraints. How usually I do this kind of a question. I do it first on a paper usually, so it becomes much easier on to list all of them on a paper pencil. So on a paper pencil, I do this even before going to the Excel. But let's fill out these things. Maybe we can just fill out. So because they have given us this grid, so I think it's easier to do it here. But for Excel, I will still do it on a paper pencil first and then go to Excel. So what's happening? So the first thing they're saying, so here, there's a budget constraint. So the first constraint, so these subject to means constraints. So maximize this function or maximize this, this function but keeping these constraints, subject to these constraints. So all of these are constraints. So the first constraint they are talking about is so they cannot go above $10,000. So whatever they do in between these two, N and R, you cannot go above $1,000. So here it technically means N plus R is less than equal to $1,000. So the simple, it's this constraint. If I write it on a paper, I will put N plus R less than equal to $1,000, which means one of this and one of this. So you got this point. So it's how we, sorry? So the first constraint is telling me from this one that 100, the advertisement on the newspaper and the radio cannot go above $1,000. So if I have a paper pencil, I will write this thing as N plus R less than equal to $1,000. All right, so let me. So what is it called? Is it called one note? Okay. So this constraint, wait, I'm just trying to connect to, so can you see this, my notepad?
Yeah.
All right, so technically this is technically it's just this constraint. All right, what's happening? I cannot really. I think if you think about it, we are just writing this like this is less than and equal to 1000. So this is just one constraint. So if you put n about 500 and r for $500, so their sum cannot go above $1000. So if I have to put this equation in here in this form, I'll put 1n and 1r because there is actually 1 and 1 in here.
Yeah, but does it give you the value of N and R? Like the cost?
No, it's just the constraint. We have to find n and r in this equation. So when we solve it for maximizing the revenue or exposure, we are changing the values of n and r, but we don't know how much an n and r can be because there are a lot of constraints on them. So in combine, if you combine both of them, you cannot go 1000. Are you getting this point? So this is one constraint. So n can be 500, r can be 500, and they combined total becomes less than equal to 1000. But n can be also 100, and this can be a 900. We don't know. It depends on other constraints and the total profit. So if someone is making more profit only using n, they can just make 1000 of n and r equal to 0. But we have to put as a constraint that n plus r is equals to less than equal to 1. So this is one constraint coming from here. Then management decided that at least 25% of the budget must be spent on each type. So if you think about it, so minimum, so they are saying at least 25,000. So this is our budget, and 25% of this would be $250. Right?
Yep.
So if we talk about minimum of newspaper budget, I'll say another equation I'll say is like n is less than equal to 250. Like each like an r is less than and equal to 250, because management is saying at least you have to put 25% of your budget, which is $1,000, and I have to put an n, and I also have to put 25 in n, so the n value cannot go below 250. Are you clear on these two constraints?
Yeah, but wouldn't the sign have to be the opposite way? Wouldn't it have to be like they're greater than 250?
Oh, yeah, sorry. Yep. So I just, yep, it should be like this. Yep. Yep, you're right. So they should be like this. So
yeah, I got that.
yeah, so we can put this so 1n, this will be 0 now, and 250. Similarly, this can be 0, and with our minimum is 250. And then so the third one is an always constraint, like n plus r should be greater than 0. Oh no, this is not that constraint. I think this is like allocation minimum ratio. Oh no, I thought this is the general constraint, which is always there, that we have to use some of them. So the third constraint we have to think about is allocation minimum ratio. So here they were talking about Yes. So here, when they talked about at least they have to give 25% to each of them, each of the media types, and the amount of money spent on local newspaper advertising must be at least 3 times the amount spent on radio advertising. So technically, forget about that, but we are saying newspaper should be greater than equal to 3 times of R. Is that what they're saying? The amount of money spent on newspaper should be at least, so greater than or at least 3 times the amount spent on R. Yeah, I think this is correct. All right, so does this make sense to you? Hello?
Sorry. Would the
Yes.
number in front of N be 250 and the number in front of R be 750? And then it'd be greater than or equal to 1000?
How's that? How's that you're coming up? I don't know, maybe
Or,
because N has to be at least 250.
Yeah.
But it can, you're saying so N, but we cannot use the minimum because if N is above 250, for example, it's 300, we have to hear 900. Then we have to keep, um, so we have to keep this one as is, this one as 0, and this one as 3. This is what I'm thinking. So this one as 1 here. Let me check. Yeah. So do you have the same values, I think, or maybe they
Yeah.
change a little bit?
Yeah, I do, I think.
All right, so then, yeah, so this is the answer technically. So have you got this point? Like, this is another just a constraint. So it's not between the budget and NNR, it's between NNR together. Like this constraint is like with relationship with NNR, not, so first 3 were with the budget, like NNR total cannot be greater than 1,000, N has to be at least 250, R has to at least 250, and then N has to be always 3 times of R, at least.
Yeah, I understand that part.
Okay, all right, good. So were you able to do it in Excel?
No, that's one of the things I couldn't do.
Okay. All right, so in Excel, let's also open the example we have. So in here, so this is our Excel example. So in here we had this kind of objective function, and then we have all the constraints one by one. So what we did here, we put a column for first constraint, the first variable, second variable, and then profit. And this formula is always important, sum product. So let's do one by one. So we also have 2 variables here. We have, if you think about variables, decision variables. So we have newspaper and we have a radio. And we can allocate our budget between these 2. So for example, if we think we have 0, 0, because these These are the two things which have to be changing, which have to be which have to take different values. And then here comes the exposure. Exposure. Just a second, Daniel. Let me check this. Please just hold on.
Yes. Sir.
All right. Sorry about that. So we have exposures this is our, so I'm just following this example technically. So I'm just following, so these are the changing values of, I don't know what changing values of newspaper and the radio and exposure. This will change our exposure to, we had 50 and 80. All right, so this is our, so we have to change these values. So, and this is our maximum exposure we can get. And then our total, or we can say total profit or total exposure in the end would be based on some product of this array, changing these two values and multiplying these together with them, with these two. So this is our objective function. Are you clear on this formation? So I'm just trying to follow this example. And as in this example, we put subject to here. So there are different constraints. In here, we have these three constraints. So I'm trying to, all right, so we can do this. We can just type this one. We can type this one. I think we can easily type all of them without putting anything here. I can actually, there are two ways to do it now. We can either type all of them in here and select the cells, or we can just directly go to the solver and see what we need, which is not here, and then we can type in. So I will show you what I'm talking about. So let's go to solver. This is the place where we go and solve this.
I downloaded that.
Okay, so you should have this thing in your computer, and then, so the set objective. So this cell is this one. We want to maximize our allocation. So it's maximize is good by changing the values of these two cells. We're all clear on this?
Yeah.
So I'm saying this is my objective function. This is my total. This is a sum product thing. So always we have in this kind of a problem, linear optimization, we do sum product, which means multiplying this with this very changing value, and plus multiplying this one with changing value. So it's like x1 into 50 plus x2 into 80. So, and then we can put it in Excel as a sum product thing in here. So we have to maximize this one by changing these values. So these are constant, these cannot change, but these two can take different forms, different numbers. So we can allocate different numbers here, but we don't know how much because it's subject to some constraints. So we can change these. So these will this will be just selecting this. So it's B4, C4. Technically, we can also just type B4 colon C4. These dollar signs just show that they are not changing. If we drag this column down, this will remain same. We can just type B4 colon C4.
Mhm.
Those will be just these two cells. Now we have to put all these 4 constraints. So let's add constraint one by one. So the first constraint we have is that n plus 1 is less than equal to 1000. All right, so the first constraint we cannot even put. Okay, so let's put. So I'm putting here some. I'm making one more column, or just let's do it easily here. So this is like constraint number 1, and it is about and sum of this one. I think that's it. We just needed this one technically to put it in the solver, because we cannot do sum here. So what I want to do here, I want to just select this cell, which means that I'm saying sum of 1 plus n and r, n plus r is less than equal to 1000. Getting my point or not?
Yeah.
If another way to do it is like, I would have selected B4 plus C4 is less than equal to 1000, but I cannot do in this cell. This cell just can take one cell. So I have to make a cell here, which is like B4 and C4. It's just sum of B4 and C4. We can even, we can just even write here B4 plus C5, oh, C4. And then go to our solver and add a constraint of this cell less than 1000. Add another, which is this one. This cell has to have greater than or equal to 250. This is my another constraint. So I have 2 constraints now. The first one is this one. This cell has to be less than 1000. The second one has to be greater than or equal to 250, which is this cell technically. And then I can add another one. This cell has to be greater than or equal to 250. And then comes the third one, which says this cell, n, the value of n has to be greater than equal to 3 into r. Now this can be problematic. It may not work in Excel like this. Oh, it worked. That's fine. Any questions on this? We have to use simplex method. Daniel, any question on these 4 conditions?
No, that's just a lot though.
That's a lot. All right. No, that's actually all right. So have you seen my video? So that was very basic. You must really know how I did in the video. Then this is not that hard actually. Yeah, it's I think the graphical method should be done more before going into Excel. Maybe that will clear up things. So by drawing from hand, like using graphics,
Yeah.
because in a graphical method, you will draw equation for each of these. So it will be like lines crossing, and then you can see the area somewhere.
The shaded area.
Yeah, the shaded area would be actually the best area, and the furthest in that area is the solution. Let's try to solve this. So it actually gave us our answer, and it says we should allocate 750 here and 250 here. So these two were 0, 0 in the beginning. but now they have the optimal solution. And this is like, as we said, it should be less than or equal to 1000. So we actually put this one just b plus 4. So it took the values from here. And the maximum is 75700. So that's one way to do it. Graphical is another way to do the same thing. But I think like I could have drawn all of them here. We can even draw now. It's just the same thing. I just entered all of them one by one in here. So the only thing, like in the example, in this example, we draw this thing, everything, just to enter in the, like, this thing in the end is just to enter in Excel. That was the only goal. Didn't do anything. It's just about entering in Excel. So this was easier. We can just directly enter everything in Excel. So what's your exact question? Like why you're saying it's too much? Hello?
Sorry, my thing keeps on going on mute. I I was just exaggerating a bit, I guess.
Okay. Yeah, I think it's not that hard if you, yeah, I will record this video and I will upload it so you can take a second look. Yeah, so it's not that hard. Once you have figured out the constraints, you have to just enter one by one in Excel by changing. So there are three things in every problem. There is a maximum function, maximization or minimization function, by changing certain values. So these two values were changing. So in the first step, we will enter them 0, 0, just a placeholder. And these are just constant. So they will take a product of these two and product of these two and then sum it up. That's what exactly it's here. It's a product of these two and product of these two and then sum. Either we have to maximize this sum or minimize this sum based on the constraints. So
And then I just use that, and that like pretty much applies to all the problems. I just have to name all the constraints in the solver.
exactly, you have to just name all the constraints in the solver, and sometimes solver can just take one value. So there's a constraint like b plus c less than 1000, or it's a b plus c plus 10. You will just make it here. You will just put a constraint here, because in the solver, in the constraint area, you cannot do here a computation. You can say b plus c plus 10. So you just make a cell here, b plus c plus 10 equals 10, and you just select the cell and then put a constraint equal to, less than, equal to, whatever. So it's not that hard. If you want, I can go over this one. This is, I think this is the hardest one or the biggest one. Have you done this one?
I looked at it and I was just like,
Sorry?
I looked at it.
Yeah, so this is the biggest one, but I think it's not that hard if you think about all things. Maybe we can go over. So this company is trying to manufacture some batteries for mobile phones, and they want to sign a contract with a contractor. So they have mainly three different battery packs. So there's PT100, PT200, PT3. So they want a production of at least, they want these many, this type, and 100,000 of this type and 150,000 of this type. So this is their requirement. So they have two options. They can either manufacture them in Philippines or Mexico. And there are constraints too on that. So they cannot go like, we should manufacture, if all of them are like PD 100 is cheaper in Philippines. We should make all of it 200,000 from Philippines. No, they cannot do this. And there's also a shipping cost attached to it. So they have to make some part of it from Philippines and some part of it in Mexico. And then if they make too much of the first PT 100 from Philippines, they cannot make 200 from there, which may work better because this is expensive in Mexico again. So we have to work on constraints. So we cannot solve this problem pretty easily without using linear optimization due to all the constraints.
Do I what?
Due to all the constraints, we cannot manually solve this problem like just by guesswork or by other problem. We have to use linear optimization method like a simplex method, like a graphical method, or like this one using a simplex method. So the maths behind is actually simplex method is called we haven't really discussed the maths behind it, how this works, but we have to Excel can do it for us. So these are the cost per battery. So these are per battery per plant. So this is just in Philippines and this is just in Mexico. And they have given us all of this. So the first thing we should do here, we should just try to, like as we did here, we put variables and their different values. So let's put variables. Now we have PD 100, PD 200, PD 300. So these are three different things. And we also have another type. So it's not a very linear kind of a variable like we had, but each variable can be of two different types. So Mexico, okay. I'm putting 0 because I'm saying my quantities. So these are the quantities, these are the values which will be changing when you make the minimum cost. Are you getting my point?
Yeah.
So minimum cost we have to find, and this would be this. All right, so let's do so variables and so let's go a little bit more, read a little bit more. So the unit cost of a battery differs at two plants. So yeah, we got this part. Because of the wage rate, the unit cost of each battery at each manufacturing is as follows. So they have given us unit cost. And PT 100 produced using similar. So they're talking about constraints. But yep. So I think what we have to do here is also so I'm making another table here, which is just for the cost. Because I will need this thing in my computation. All right, so this table, this first table is the changing table. So in my solver, I will use them changing values of this table, and the cost will remain the same. The cost will not be changing, but these values will be changing based on the constraints. What I missed here, so there is another information here, is that the cost of Philippines for shipping from the Philippines plant is 0.21 per unit. All right, so So there's a cost of shipping. All right, so if you think about cost, total cost of, I would say total cost P, or Philippines cost, and total. So this value, so because each of them will cost 0.21, and for the Mexico, it will cost 0.08. So this one plus this, absolute. And I can drag this. Got my point or not? What I'm trying to do here?
Where do
So there's, so I have put here the actual cost for Philippines, and I have put here the cost for Mexico for each unit, but there's a shipping cost for each unit. So the shipping cost is like 0.21, 21 cents. So we have to add this to this part. So I'm adding 0.95 plus 0.21. So it's just adding 0.95 plus 21. That's it. And then adding in this 1.21. So the total cost comes to this, not this. This one just includes the actual cost, but this one is the total plus the cost of production plus the shipping cost.
Yeah.
All right. So this one would be the total cost for Philippines, and this one would be this plus this product. So this one goes for all of them. So 0.0106 plus 0.08, 1 point. So yep. So it's all correct. All right. So I think it's just too many cells. So what I'm doing here, I'm just removing few cells and deleting the, so understand this. Okay, what I did here, I've just maybe made more confusing, but this is 0.95 plus the shipping cost 0.21 is 1.16. That's the total cost for Philippines, and total cost for Mexico for any product we can. So 0.08 we have to add. So it was 98.98. We just add 8 cents. It became 1.06. So these are the total costs, and then we can do, first thing we have to find. Okay, so these are all the number of constraints, number of variables. So this is P1 is one variable, which actually refers here to this cell. If you think, is the number of PT 100 made in Philippines, and P2 is actually referring to this cell, and P3 is actually referring to this cell. Similarly, M1 is this, M2 is this, M3 is this. So we have to minimize our sum product. So this is our minimization function, which is like this one, whatever we have here, and this is the cost. So whatever we produce, number of Philippines made batteries and the cost for each one of them, these two will be used in the sum in product.
Yep.
So my point is, we can do sum product function in this way. We can do like this. This is our one side, and this is the other side. And that's it. This is our objective function, which actually means that we already have P1, P2, P3, and everything here. We just have to put this one here. So this is our cost of producing 1 unit of P1 with including the shipping. So we have to put the actual cost, which is coming from here, plus the shipping. It comes out to this. So this plus shipping is this number. And we have to minimize this whole thing. And the second one comes from this, and third one comes from this. So M1 comes from 0.06, 1.14, 1.23. All right, so this is now our objective function is good to go. Now we have a lot of subject to. Subject to, I will go back to my paper, pen and paper. What I have to do here, I have, this is my function. I'm trying to minimize this thing with 1.16 P1 plus 1.19 plus P2 and 1.55 P3. I'm just writing down so just later on is easier for me to follow the symbols. All right, 1.23 M3. All right, so these are our, this is our function ST. The first console, let's work on the constraints. So their constraints start from this section. So they're saying PT 200 battery packs are produced using similar production equipment available at both plants. Okay, however, each plant has a limited capacity for the total number of PT and PT. All right, so this is one constraint, but first constraint is actually coming from here. First three constraints actually, production of this one. So whatever we do, we cannot go above, because the company does not need more than 200,000 of PT this thing. So 200,000 of PT. So if I make one of this and nothing else, I just need this one at least. I need PT 100. So here, P1 is equals to 1,000. So we already know this. We need this. We need, it's 200,000. And similarly, P2 is equals to 100,000. P3 is equals to, we need this. We cannot go above or below. There is no point of making more than this or less than this. So these three constraints, all right, so there's one more point. So P1 is only the production in Philippines. They're talking about PT 100, which can be made in both the countries. So we have to put it P1 plus M1 and M2. Getting my point? So this is important. We should focus. So we need this type total 100,000. Either we make it from here like in Philippines or Mexico. We need type 2. Either we make it at Philippines or Mexico. We need 100,000. And P3, either we make it in Philippines. We can divide the work, but we need 150,000. So this one should be 1. And then this one should be 1. This one should be 1, 0, 1, 0, 0. Nope, not 0. How much is it? 100,000. So I'm just changing. If you can understand this constraint, then it's easier to understand here how we put it. So we are just saying the type 1 because the first constraint is talking about production of PT 100. How much do we need? We need 200,000 of it. And this looks less actually, this number. No, it's good. Same way, this is P2 and M2 is 100 is equals to 100,000, and then this one would be 0, but this one P3 would be 1. This one would be 0. This one would be 150,000. Any questions on this?
No, I understand that now.
Okay, that's great. Let's little bit check our work. How are we doing? All right, so this is all look good. Now it starts the real problem. Like, so this was from the this is given. This is from here what we need. Now there are few more constraints, like how much we can make PT 100 and PT 200. So they're saying each plant has a limited capacity for the total number of PT 100 and PT 200 battery packs produced. The combined PD 100 PD production capacities are 175,000. So I think so. Since both can produce PT 100 and PT 200, both can be produced, but here they're talking about capacity at Philippines. So this one and this one, let's remove all of this, and this is equals to 175, whatever it is. Okay, all right, so this is the number, the total, the combined PD 100 and PD 200 production capacity. So they are talking at Philippines. At the Philippines is 175,000 at Philippines. And for M1, and they're saying for in Mexico, the same product would be, we can make up to 160,000. And this would be like this. So here we have P1, P2 equals to 175,000. And here M1 plus M2 equals to 160,000. All right, so these are two. Now they're saying capacity of Philippine for PT 300. So how much the PD 300 production capacities are at 75,000 units at Philippines. So 75,000, and this one would be 0, this would be 1, all other we keep it 0 at this time. And for Mexico, this can be made at 100,000. All right, so this is our thing. All right, so let's check our work. And all right, so all of this is correct. So we just have to enter few all right, so we have to enter constraints now. So the first constraint is coming out to be, it's too much. All right, so let's enter the constraint. We are saying this one plus this one is equals to, all right, so I will list all the constraints. 1, 2, 3, 4, 5, that's it. So the first constraint is this plus this. And is, of course, we can put in the solver that it is less than equal to 200. 200,000. But the only thing is that we just be able to, and the second constraint is this plus this. Any questions on this, what I'm doing? Yep, so it's just pretty straightforward. And then it's another constraint is P1, which is this one, plus P2, which is this cell. And the last constraint is M1, which is this, and M2, which is this cell. All right. I think this shouldn't be equal. I'm not filling up this thing because we can all, and this cell because we can do it in solver. I think that's all the constraints. So let's go to solver. So we have to change set objective value, changing this this value, or the minimize this value. So we have to minimize this value, and by changing these cells on subject to constraints. So the first cell is this cell has to be equal 200,000. All right, then second, P2 and M2 has to be equal 100,000. Third is this cell is equal to 150,000. Oops. So we have 3 constraints right now here, but I just want to take a look here because yes, I was missing these. So less than, equal to. So there are 3, 4, 5, 6, 7. Why do we have just 5? I don't know. 3, 4, 5. So where are the last 2? So there's another constraint. What we actually missed is P3. So this one, P3 is less than equal to 75,000 and M3 is less than equal to 100,000. And these are actually less than equal to, these are less than equal to. Going back to Excel, we already entered these three. We can enter more. So we just entered first three. The fourth one is this one. This is less than equal to 175,000. And M1 plus M4, which is this constraint, is less than equal to 160,000. And then M3, which is just this cell, P3. P3 is this cell. This has to be less than 75,000. Adding the last one is this cell, M3, is less than 100,000. All right, so these are all the constraints, I believe. We can change this to simplex method and press solve. So it just solved it. We can also run sensitivity analysis. Oops, I don't need the limits. So it actually solved this box solved, and this is like automatic generated from here. So it actually solved it for us, and it comes out to be, this is 40,000, 160,000, 100,000, 0, 50,000, 100. Total cost comes out to be 535,000. So here, let's first run this analysis and see how accurately. So we did pretty accurate. So all the results are pretty good. Now they're asking how much is the sensitivity analysis. So sensitivity analysis is like how much we can change some of the values, but still get a good answer or still remain in the range. So some variables or some values are flexible, some are not. And some values, even if you change it little bit, the maximum value will stay the same. It will not affect the maximum value. And this is like leveraging. So they are saying how much the production or shipping cost per unit would have to change to produce additional units for PD100 and Philippines plant. So they're saying if we changed a little bit of shipping cost or production cost, if we change the cost, we can produce one additional unit while keeping our maximum in here, maximum production, while minimizing the overall cost. So this is the report which was generated by clicking on sensitivity report. And if you go in here, did I press sensitivity in the solver? Okay, let's go back here. Let's do simplex, let's do solve. Sensitivity. This is showing me Slack. 1, 2, this is the second report. I think this one is much, I don't know. Let's see. because this is not the right option. I'm looking for sensitivity results, but not able to find it. All right, I'm looking for other options. Hmm, this is our sheet. So we did a cost here, and we really cannot change the cost overall because we didn't put the, we're not changing the shipping cost. So why don't we find, so this is our total final value for, so they're talking about, so this is our Mexico value. We need something for here for the, these are all for Mexico. We also needed for our, I don't know why it's not showing me all the results. So it's pretty crazy. So this is for Mexico, and let me think. So I have this value here. I don't know. Yeah, it should be showing me, like as they're showing me constraints for Mexico, and they should show me constraints and variables for, so what is this B3 and C5 in my B3 to C5? So they're showing me all of them here. I don't know. Yeah. So variables are not being produced for some reason. Everything is actually pretty good. I don't know why. The answer is pretty perfect. Everything is perfect, but it's not showing me a sensitivity analysis for some reason. Even I have put the cost. Oh, it's here, hidden. All right. I was like, why it's not showing me? All right, Daniel, are you there? So have you got this point, all of this, like how we did this?
Yeah.
Like formulation and everything, like we have put here, there are actually two more I didn't put here, but I actually entered from here, like just by selecting, because it was just one variable, like it was just P3. So I just select P3 less than equal to whatever the value. So there are two more here, two more constraints. And then once we press solver, it gives us new values for this box, which is just exactly this box. And then this value comes from the minimization of this box while keeping the constraints. Then they're asking how much the price or production, how much the production cost for a unit should be changed to produce an additional unit of PT 100. So report also gives us like if we want one more unit within the same cost. So we are not increasing the cost, but just decreasing the shipping cost. If we can negotiate at least like going down 0.05 for shipping, we can get additional unit of PT 100. So this number allowable decrease. So this can be decreased. And this number is 0.05. So sensitivity, you have to look for this number. For any variable, how much is allowable decrease we have. So we are looking for this number. And here they're asking us to use sensor analysis to determine how much the production cost or shipping cost per unit would have to change to produce additional unit for PT200 in the Mexico plant. So, oops, what really happened? All right. So this comes out PT200. Oh, is this one actually PT200 Mexico is also 0.05. So I'll put here 0.05. So this is all done for question 2. Question 2 or question 3? Question 3, I think. So any questions on this?
No, I think that's it.
That's good. Now you can do other questions.
Yeah.
All right. Yeah, they actually, the other two are simpler. They're easier than this. If you try to formulate the way I formulated the question, it wouldn't be that hard. This is the easiest one, I think. This is pretty straightforward and easy, basic. All right, then.
Okay. Thank you.
All right. Thank you. Good luck. Thanks.
Have a good one. Stay safe.
You too. Thank you.